Okay, so here's a quick little review on being able to graph logs and exponentials with transformations based off of some parent graph. So basically the things we need to be able to know how to do is create a table of parent points. So you need to be able to pull the parent out of the equation that's been given to you and then apply the transformations in the equation. So to come up with the new points. Determine the x and y intercepts, domain, range, asymptote, and then describe the transformations from the parent. So very similar to stuff that we've done before, just now specific for logs and exponentials. So let's take a look at an exponential first. So here we have our h of x equation identified as such, and then we need to be able to set up a table. So I've kind of already set up our stuff here. And then we want to complete the tables. So you have to be able to figure out what the parent points are going to be. So we're going to talk about pulling the parent out of the equation first. State the indicated information. So same type of things we've been looking at before, x-intercept, y-intercept, domain, range, asymptotes, and then explain the transformations. And then if an item doesn't exist, don't leave it blank. Just say D and E. Don't just skip over it. And then we're going to sketch it. So let's go ahead and take a look at these points or this equation first. So if I take a look at my equation, I'm going to start pulling away all of the transformations. So I know that it's exponential because I see that the x is in the exponent. Well, x is in the exponent of what number specifically? It's in the exponent of the 4. So our parent is right there. It's just 4 to the x. The negative 1/2 is a transformation. The plus 1 is a transformation. The plus 3 is a transformation. So our parent here, which has been identified as f of x, we're going to identify it specifically as 4 to the x. So when we create our parent points, we're going to go -2 to +2 for the x's. So notice that the x is going to be our input value. -2 to 2 for the x's, and then we're just going to plug -2 to 2 in. So if I do -2 as my first point, then -1 is my second point, 0, 1, and then 2. I always plug in with exponentials. I always plug in the positive exponent first, because if I want to do the negative exponent, all I have to do is the reciprocal of the answer from the positive. So if I were to do down here at the bottom, I'm looking at, so with 2 as my input, then I would do 4 to the power of 2. So that's going to give me 16. So now, if 4 to the positive 2 is 16, then 4 to the negative 2 is 1/16. I just take the reciprocal of it. So I always do the positives first and then fill in the negatives. 4 to the 1, so I'm down here now. 4 to the 1 is 4. So 4 to the negative 1 is 1/4. And then 4 to the 0, well, that's just 1. Okay, so those are my parent points. So now what I'm going to do is I'm going to start applying my transformations to it. So if I go back up and I just look at the x's themselves specifically, and I'll color code that in blue. So I look at what's happening with my x's up in that exponent. So it looks like x plus 1. Remember, whenever we're talking about the behavior with transformations, with x, it's always the opposite of what it looks like. So x plus 1 means we're actually going left 1 unit. So we're going to take our x's and we are going to subtract 1 from them. So I'm just going to put it as a point up here. So I'm going to take my x and I'm going to minus 1 from it. So I'm just going to do those first. I'm just going to take all my x's and subtract 1. So take the parents, subtract 1 from all of them. So that's going to give me -3. Actually, we don't even need the points. So let's do -2 minus 1. I understand you know what that is. I'm just making sure that I write this down so that you can see what I'm doing. So I'm just minusing 1 from all of my x's. And then I can just go ahead and start filling those into the table. So this is going to be my first point is going to be -3. And then -2, and then -1, and then 0, and then 1. Okay, now for our y's, we need to go through and figure out what's happening with those guys. So for our y's, we do exactly what's happening, like what it looks like. So what I'm going to do is I'm going to take this stuff that I've already color-coded here that pulls out the parent. Don't really need that anymore. it also pulls out the transformations from the x. Everything else is stuff that applies to the y. So I'm going to have this negative 1/2 times my y value, so the stuff that comes from the box, and then plus 3. So really what I'm looking at here is negative half y plus 3. And I'm going to go through and fill that into the table. So if you want to pause it now, it's a great time. Go ahead and fill in the middle stuff just to get yourself in the flow of this. And then we can do the calculations and figure out what the y values are going to be. Okay, so check yours against mine. All I did was just plug in the y values. Now we need to do a little bit of math. So if I take a look at this very first one, this negative half 1/16 plus 3. Okay, what I'm going to do is I'm just going to multiply those two together first. Remember, we multiply fractions straight across, so this is going to be negative 1 over 32. Then I have a negative 1 over 32 plus 3. So I've got a negative and a positive, which means I'm actually going to subtract the two. Don't make this overly complicated for yourself. If you have negative 1 over 32, then you have a fraction of 1, and you're adding 3 to it. So you're going to have 2, and then whatever's left over from that 1 that you're taking away. So this should give me a whole 2. Well, let's put our little commas in here just so I don't get my points flubbed up together. So that's going to give me a positive 2. And then I have 1 minus 1 over 32 from it. So that's going to be 31 over 32. So again, don't superly overly complicated. Actually, keeping it as mixed numbers is probably going to be good. So we have a ballpark idea of where it is in the graph. So I'll do the same thing with the next one. So that's going to give me negative 1/8 plus 3. So I'm going to have 2. And then negative 1/8 from 1 gives me 7/8 left over. Negative half times 1 is negative half plus 3. Okay, so I'm going to have 2. And then half away from 1, half. And then negative half times 4. Okay, this is good. This is negative 2. Now we don't have to deal with fractions anymore. Well, so far. Then we've got negative 2 plus 3, so that's going to give me 1. And then negative half times 16 is negative 8. Negative 8 plus 3 is negative 5. Okay, so I've got my points now. Now, when I plot this, I'm not going to be super overly worried about the first 3 fractions. I'm basically going to plot probably the 2.5, the 1, and the negative 5, because I think that's reasonable, and then get an idea of what the sketch is going to look like. Okay, so now moving on, we've got our table created. We want to let's see if we can pull any information directly from this thing. So I see a point that is 0, comma. That means that I have the y-intercept. So I've got 0, 1 as my y-intercept, which is nice. X-intercept I don't have. Maybe we sketch it and see first. Domain, I already know what the domain is. If you have an exponential graph, the domain is all real numbers, which is actually kind of nice. We don't have to do any extra work with that guy. Range, I do know what the range is, and I also know what the asymptotes are, or the asymptote, the single asymptote. If you're graphing an exponential function, which is exactly what we are doing here, I'm going to take a look back at my graph, and I think I'll go ahead and grab a purple highlighter. So I know I've highlighted the whole thing. If you were looking at the asymptote or trying to find the asymptote for an exponential, the asymptote is always the k value. So it's going to be this guy, that plus 3 down at the very end. And exponentials always have a horizontal asymptote. Horizontal asymptotes are always going to be y equals. So my horizontal asymptote is y equals 3. Okay, so my graph then, maybe we sketch this thing. Let's see what this looks like. So go ahead and set up a graph. You don't need to make it super large. It looks like the smallest y value we're going to do is negative 5. The largest y value we're going to do is maybe 3 or 4. And then the x's are going to go from negative 3 to 1. So let's go ahead and set up a graph, get those points plotted. Let's sketch our asymptote also. Okay, so I got the negative 1, 2.5, 0, 1, and 1, negative 5 plotted. I think I can see what this thing's going to look like. So let's go ahead and give it a decent sketch. Remember, with an exponential, we definitely do not cross or hit the horizontal asymptote. So give it a decent sketch. Make sure, and just kind of follow the points as they're going as best you can. And it does look like we're going to have an x-intercept. We're going to have to find it though. So that was one of the reasons why I waited, because I was like, okay, well, let me see if this is actually going to hit the x-axis or not. There's no point going through the calculation if it's not actually going to happen. Okay, so x-intercept I'll come back to. Range though, for sure I know what this is going to be. So it looks like it's going negative infinity and getting as close to the horizontal asymptote as possible, parenthesis, no bracket, because it's not actually going to hit. X-intercepts. Okay, so to find the x-intercept, I'm going to plug in 0 for y. So if I plug in 0 for y, I had to do some calculations. See if we can find some space for this. Actually, I think I'm just going to erase some of the directions up at the top so I can do some work up here. Okay. All right, x-intercept. So to find the x-intercept, I'm going to plug in 0 for y. So I'm going to get 0 equals, and then I'm going to go ahead and take my equation. Negative 1/2, 4 to the x plus 1 plus 3. Okay, I'm trying to solve for x. So let's go ahead and minus the 3 to the other side. So that's going to give me negative 3 is equal to negative 1/2. 4 to the x plus 1. Get rid of the negative 2. So if I multiply both sides by negative 2 to get rid of the negative 1/2, it's going to give me positive 6. 4 to the x plus 1. Don't need the parentheses anymore. Whew, it's a little tight fit up here. Okay. I got to get the x to come down, so I'm going to use logs. And I'm just going to rewrite it as a logarithm. So it's going to be log the base of the exponential, the exponent on the other side of the equal sign, and then what was the answer to the exponential. Okay, and then minus 1. So log base 4 of 6 minus 1 is equal to x. Okay, so there's my x-intercept. Make sure you write it as a point. So it's log base 4 of 6 minus 1, comma, 0, because we plugged in 0 for y. Okay, the last thing that we need to do is take a look at this and see what we actually did to this thing. So if I take a look at the x's, I'm just going to go back and take a look at the table itself. So if I look at that, I can actually describe what I'm looking at. So like highlighted in light pink. I know, all the highlights. I took my x values and I subtracted 1 from them. Okay, by subtracting 1 from my x values, I went left 1. So let's make some bullet list here. So I went left 1. Okay, then with my y values, I took my y values and I times them by a negative number. So what was a positive y value turned into a negative y value. What was a negative y value turned into a positive y value. That means that I did a vertical, because the y's are in the vertical direction, I did a vertical reflection. So vertical reflection. Then, so that's the negative of the half. Then I did the half. So I took all the y value, like distances between the y values, and I times them by half. So that means I shrunk the distance between them. So if I had y values that were 8 units apart after I times it by a half, then that means the y values are 4 units apart. So what I did was I did a vertical compression. So vertical compression or vertically compressed by a half. So took the distance between the y values and shrunk it. Then, so that takes care of the negative and the half. Then the last thing I did was I added 3. So that means that I went up 3. Okay, so if we look, I have got 1, 2, 3, 4 things that were done. So let's take a look. So I've got up at my pink highlight. There's 1, 2, 3, 4 things that were done. Looks like I took care of everything. Okay, that's it for my exponential. Well, let's take a look at a logarithm. So go ahead and set yourself up, get ready for this guy, and then come back and let's start filling some stuff in. Okay, now we need to rewrite this thing. Because of the 2 coefficient on the x, we want just x. So I'm just going to rewrite this just above it. So we're going to do g of x is equal to 2 log base 3. I'm going to use brackets just so I can differentiate between parentheses. You could just do 2 sets of parentheses if you want. Factor out whatever the coefficient on the x is, just like when we did transformations. And then we're going to have x minus, make sure you factor the 2 out of there as well. Okay, do a quick check, make sure that if you distribute the 2 times x, you get 2x, and then 2 times negative 2, you get minus 4. Okay, now that we've done that, now we can figure out what the parent of this thing is. So the parent is going to be the log base 3 of, and it's just the x. Remember, you pull away all of the transformations. Everything else in there is a transformation. So our parent here is going to be, which we identified again, I think, as f of x. So we're going to identify f of x as log base 3 of x. So I'll put that over here. Log base 3 of x. Okay, so here's what we're going to do. We're going to use the idea of the fact that exponentials and logarithms are inverses of each other. So previously, back here, I chose all of my x values to be negative 2 to positive 2. Well, I'm going to reverse that, or kind of like invert the two of them. So instead of negative 2 to positive 2 for the x value, I am going to do negative 2 to positive 2 for the y value on this one. So I'm going to go through and do, okay, negative 2 for the y, negative 1 for the y, 0 for the y, 1 for the y, 2 for the y. And I'm just going to treat it kind of like an exponential here. So if I used those as the exponents on a base of 3, so base of 3, because that's the base of my logarithm, then I should be able to figure out what the appropriate x values are. So if I did 3 squared, so I'm down here at the bottom now, so I'm using the 2 as the exponent, using the exponential aspect here, on the base of the logarithm 3. So I would say 3 squared is 9. Okay, I'm going to do the same thing that I did before. If I do a negative exponent, then that means the top here is going to be 1/9. Okay, so now I'm going to do 3 to the 1. Well, 3 to the 1 is 3. 3 to the negative 1, that's going to give me 1/3. And then 3 to the 0, that's going to give me 1. These are the exact same points if I did like y equals 3 to the x, but I exchanged the x and y. I'm using the whole inverse part of exponentials and logarithms. Okay, so these are my parent points now. Now I'm going to go through and do the exact same thing that I did previously. I'm going to take a look at what's happening with my x's. So on my x's, got this 2. Remember, we do the opposite of what it looks like. It looks like it's multiplied by 2. We're going to divide by 2. And then I see that minus 2, but I know I'm going to do the opposite of it. So it looks like minus, I'm actually going to plus. Why don't you see if you can set up what's going to be happening with the x's and then come back and check yours against mine. Okay, so let's see if you set this up correctly. So we're going to take our existing x value, whatever it is, instead of multiplying it by 2, we're going to divide it by 2. But since we have fractions, dividing by 2 is the same thing as multiplying by a half. So that's what I'm going to do. And then instead of subtracting 2, I'm going to add 2. So that's what we should be doing with our x's. Remember, follow order of operations. So like multiply divide is going to happen before add subtract does. So the multiply is going to happen first, then the add's going to happen second. Okay, so let's take a look at your y's. So with the y's, it's everything else around, so nothing that's highlighted yet. So we've got the 2 out in front and then the minus 1 at the end. And again, with y's, we do exactly what we see. So with the y's, we're going to take the existing y, we're going to times it by 2, and we're going to subtract 1. So that's what we're going to do with all of the points. So if I go through and I start filling stuff in, which you might want to consider doing, so like pause is a great thing, times by a half, and then add 2. And I know writing all this down in the middle might not seem worth it and kind of time consuming, but chances are pretty good that you'll catch a mistake if you make one. And then watch your positives and negatives here. This one's not so bad because all of the x's are positive, but still, just be careful. And then with my y's, I'm going to do 2 times the existing y minus 1. 2 times the existing y minus 1, all the way down. Okay. I am going to go ahead and just fill in all of my x's and y's for my g of x function. So now's a good time to pause this, see if you can fill in all of the points. Remember what I said about using mixed numbers? It just gives you a better idea of where those points would actually be, and then come back and we can pick up there and start figuring out what we're going to graph. Okay, so check your points against mine. I did leave them as mixed numbers. I'm going to make it a little bit easier. I'm not going to plot the 2 and 1/18 and the 2 and 1/6, but I think the 2.5, 3.5, and 6.5 is reasonable. So I'll go ahead and plot those. And then I want to see if I can already determine the asymptote, which I know I can. So with a logarithm, the asymptote actually comes from what makes the inside of the parentheses, so the thing inside the logarithm, what makes it 0. So what I'm going to do, I'm going to use, I know, all the highlighter. I'm going to look and I'm going to highlight in yellow. Now, I'm going to go ahead and just use the factored version of this. So the fact that I took the 2 out and then I have the x minus 2. So I'm going to look at that part, which I've already highlighted in yellow up at the top. So take a look there. Now, I'm going to undo that because I don't need to take a look at the 2 part. I just need to really look at the x minus 2. So whatever makes that 0 inside, whatever x value that is where my vertical asymptote's going to be. So my asymptote's actually going to be at x equals 2. So I'm going to go ahead and put that on my graph. So if I have x equals 2, and just a reminder, logarithms always have a vertical asymptote, and it's always the thing that makes the inside 0. Okay, so now let's go ahead and plot some points. So I think 2.5, -1 is reasonable to plot. I think 3.5, 1 is reasonable to plot. And then I think 6.5. So 1, 2, 3, 4, 5, 6.5. 1, 2, 3. Okay, I think that's reasonable. Okay, so I can see the curve of what looks like the logarithm graph. So let's go ahead and give it a sketch. Remember, it's going to hug the asymptote, definitely never hits it or crosses it at any point in time. And logarithms kind of look like they flatten out, but they don't. They just kind of slow down as they go further away from the asymptote. Okay, if I take a look at this graph, I know what the range is now. The range is all real numbers. This thing's going to go all the way down and it's going to go all the way up. I even know the domain. It's going to start immediately after 2 and take off to the right. I see that there's an x-intercept. I don't know what it is. I got to figure that out. But I also know that there's no y-intercept because it is not going to hit. So this does not exist. And then we'll come back to the transformations in a minute. Okay, so x-intercept. All right, x-intercept's going to require some work and some space. So I'm going to do the same thing that I did before, and I'm just going to erase the directions up here. See if I give myself some room. Just trying to keep it all on one slide so you don't have to bounce back and forth. Okay. So if I'm trying to find an x-intercept, and that means that the y value is going to be 0. So I'm going to do 0 equals, and then I'm going to go back to the original before I factored anything out. If I change my mind, I can always make an alteration as I'm going. So 2x minus 4 minus 1. Okay, add the 1 to the other side. 1 equals 2 log base 3, tight fit up here, 2x minus 4. Okay, divide by 2, 1/2 is equal to log base 3 of 2x minus 4. Kind of got to the x. Let's rewrite this. So this is going to give me 3 to the half power is equal to 2x minus 4. Okay, that's the square root of 3. And then, oh, I can barely see that. Square root of 3. I'm going to add the 4. And then I'm going to divide by 2. So this is going to be root 3 plus 4 over 2 is equal to x. Okay, let's write it as a point. Root 3 plus 4. Make sure the divide by 2 is the whole thing, comma 0. Okay. And then transformations from the parent. All right, so if I take a look back at my middle part of the table, like what did I do to the x values? So the first thing I did to the x value was I timesed it by 1/2. So I took the distance between two x values. I don't know, say the distance was like 10. If I timesed it by 1/2, then that means that I shrunk the distance. Now this is in the x direction, so this is a horizontal compression. By a half. Okay, then I took that and I added 2 to it in the x direction. So that means that I went right 2. And I'm just pulling the stuff from the middle part of the table. Okay, then my y value. I took my y values and I times them by 2. So that means the distance between two y values, if it was like 3, I doubled it. So this is a vertical stretch by 2. So I doubled the vertical distance between my points. And then after I did that, I see that -1. So I went down in the y direction. So this is down 1. Okay, let's do my little checklist of things that I did here. So I have 4 things. I have a horizontal compression by a half. That means I took my x values and, so I'm doing little red check marks up at the top inside the middle part of my table. I took my x's and I times them by a half, so I shrunk them. Then I went right 2 because I added 2 in the x direction. Then I took my y's and I doubled them, so doubled the distance vertically, and then I subtracted 1 from that, which means I pushed them all down 1. And it matches all 4 of the things that I have in my list. I hope this helped.